Take a look at this question from the Nordic Math Contest. We're asked to find a polynomial p of least possible degree subject to these four constraints over here. So let's take a look at these individually, and we're going to have to use all of them. So pause the video right now, see if you can do it yourself, and then join me back. Okay, so hopefully you paused it and gave it a go yourself. Let's now work on it together. So p has integer coefficients and all roots of p are integers. So the easiest way to do this is probably just to write it out, right? Something like this. So p of x, it could also be t or y or anything else, but I'm going to go with x. It's going to be some a, right? And then we can now write out all the roots like this. X minus r1, x minus r2, x minus r3. I'm not going to write all of that out though, because it's going to be a little easier than doing that, because we've also got p of 0 equals -1. If we plug in x equals 0, we're going to find p of 0 equals a times -r1, -r2, -r3, -r4. And that tells us that all of the roots and a have to be plus minus 1. Make sure you understand why this is the case, because they're all integers. If you want to take a bunch of integers and multiply them out to -1, they have to be either +1 or -1, and you need an odd number of the minus ones in there. Okay, we'll work on the next part later, but now we know that instead of writing a, r1, r2, all of that, we can just put a plus minus 1 over here. So I'll just put a plus minus. And then for the rest of them, since we know they're all either 1 or 2, we'll write it as x minus 1 to some power times x minus 2. Sorry, my tablet is pretty bad today for some reason, so I'm going to have to write a little slower. X plus 1 to some power. Now we're almost there, but we have one more piece of information, so let's use that. P of 3 equals, actually there's another piece right here, right? Lowest possible degree. There might be multiple polynomials that satisfy this, but we want least possible degree. Okay, so P of 3 is 128. What does that tell us? So if we plug it in, we're going to get plus minus, and then 2 to some power times 4 to some power. 4 is nothing but 2 squared. So it's 2 to the 2 times some power. All right, now what is 128? Well, that's 2 to the 7th. So if we want 2 to the 7th and we want the least possible degree, we want to use as few of these as possible, right? The fewer the better. And so we want 3 of these, right? You can just check, I mean, you can set up an equation if you want, but it's very easy to just think of it yourself. Yeah, I mean, you want to make 7 out of pieces of 1 and 2. So the best way to do it is 3 pieces of 2. So there are going to be 3 of these, and there's going to be 1 of these. So 1 and 3, right? And this is going to be of degree 4, which is of course the least degree you can have. You can't have less than that. Now we want to check the sign as well, right? Because there is a plus minus and you can't really leave a plus minus in there. So let's think about that. P of 0 is -1, plug it in. Since there's an odd number of x minus 1 factors, that's going to give us -1, and this is going to give us, of course, +1, which multiply out fine. So we want this to be a plus, meaning that our final answer is nothing but P of x is equal to x minus 1. Okay, sorry, it's very bad. Okay, it's a plus. Okay, that's it. So that's the answer. X minus 1 times x plus 1 whole cube. If that's the answer you got, great job. If not, maybe just comment below your thought process and where you got stuck, and we can work on that, and I can help you figure out where you went wrong. But thanks so much for watching this video. Hopefully you enjoyed. Make sure to subscribe, and bye-bye.